So the next talk is Seiji, who stepped in for Michele, and will tell us about ALMA Lensing Cluster Survey with a multiply imaged, very bright C2 lines from a high redshift galaxy.
Okay, so thank you for the organizer to give this opportunity. So today I will talk about the great outcome from an ALMA large project called the ALMA Lensing Cluster Survey, especially about the first achievement of the spatially resolved ISM studies for typical suballunar galaxy at the epoch of the ionization. So our paper have been recently accepted for publication, so please also take a look at these papers if you are interested. So during the past decade, ALMA offers a less frame fine Fred spectroscopic window even at redshift over 6, where the ionized carbon emission is one of the helpful courant lines to understand the ISM property. But as nicely reviewed by Kristen in this beginning of this session, what we have found is that there is a large diversity in the star formation rate and seed line relation. So some of them are aligned with the local galaxy relation, while others are showing the C2 deficit. So there are several possible causes discussed, such as the low metallicity or high ionization parameter, or the lack of photodissociation regions for these seed line deficits. However, given the situation that we generally select the moderate bright targets with a spectroscopic redshift, most of the cases relying on the Lyman alpha line, so these results might be biased towards very bright object or the Lyman alpha emitter population. For instance, the latest deep Muse study suggests that Lyman alpha emitter fraction is around 30% at redshift 6. So it would be also required to perform a blind survey to understand the representative picture at the epoch of the ionization. So including this context, the ALMA Lensing Cluster Survey, called ALCS, have been carrying out a large unbiased survey. So this is one of the ALMA large program to map out 33 massive lensing clusters by setting up 2 frequency tuning, and we maximize the detectability of continuum sources as well as the line emitters. So we achieve a total area of over 100 arc square minutes with a moderate data dips, which could be even much reduced thanks to the gravitational lensing effect. So we are carrying out an unbiased wide and deep 1 mm survey with ALMA. So here shows some of the large ALMA surveys so far performed in the area versus data depth plane. So after the lens correction, we obtain the parameter space of ALCS like this. So ALCS is indeed exploring the faint regime of the 1 mm survey as well as the survey volume, which provide us with a unique object that couldn't be identified in previous surveys. So for example, about the continuum sources, here summarize ALMA 1 mm map and HST H-band map for some of the lensing clusters. Although we identify some lensing cluster with poor number of detection, we also found some lensing cluster with rich detection at the same time, indicating that we are overcoming the cosmic variance. Even with the robust SN threshold, our number of sources exceed 100, which is one of the largest source detection compared with previous ALMA large surveys. The blind line search analysis have been also done where 60 line candidates are already identified. So careful tests are ongoing, such as spurious source rate estimate, completeness, and counterpart analysis. But before going to the careful tests, we discovered a very reliable bright seed line emitters at redshift 6, which is the main topic of today's talk. So here summarize ALMA spectra and the line intensity in red contour on the HST maps. So in the first step, we detect these 2 bright lines at the same frequency. The optical near-infrared counterparts show a similar SED shape, and the peak of the redshift distribution are in excellent agreement in the case that the line is interpreted as a C2 at redshift 6, shown in this red line. Indeed, this redshift solution is confirmed with the latest GMOS spectroscopy, where we see the continuum break at the expected wavelengths. So, and interestingly, based on this redshift solution, our independent mass model consistently predicts that these 2 line emitters are multiple images, and one of which is crossing the critical line. Moreover, the mass model also predicts 2 additional multiple images in this field. So one of them falls in this ALCS coverage. So we check the ALMA spectrum for this multiple image as well. And we identify a tentative line detection from it at the same frequency as well. So based on these results, we conclude that these bright lines are the multiple images of a C2 emitter at redshift 6 behind the cluster. After the fitting routine between the image plane and source plane, we find that a subregion of the galaxy is crossing the caustic line, which is stretched out to the elongated shape observed as the arc, while the other multiple images traces the full region of the galaxy in the source plane. So the magnification value is estimated to be around 20 or even around 160 at the arc. Although such high magnification value has a large uncertainty in general, but it is not the case in this system with two reasons. First, the configuration of these multiple images works as the strong constraint, so that the estimate would not be easily changed. And second, we confirm these interpretation and high magnification values with independent 3-lens models constructed by 3 independent mass modelers. So we think that the high magnification value in this system is really robust. So here summarize the physical property of this system after the lens correction. So 3 times fainter than the characteristic luminosity at this redshift, and both sub-region and full region of the galaxy are falling on the main sequence, but star formation versus the stellar mass. And based on the 3D modeling result, we also obtain the dynamical mass, and subsequently, we also get the gas mass by subtracting the stellar mass from this dynamical mass. So the gas fraction and the galaxy size also show the average value among the star-forming galaxy at redshift 6. So we conclude that our C2 line emitter is an abundant and representative population of the sub-L star galaxy at redshift 6. Yes. So to see the direct observed picture in the source plane, we also perform the pixel-to-pixel source plane reconstruction. So first, for the one of the multiple image, which traces the full region of the galaxy. Since we find several clump features there, those are marked from A to D. So here is the source plane reconstructed map. So this white ellipse corresponds to the source plane HSD resolution, showing that we achieve a few hundred parsec scale resolution in the source plane. Okay, next, for the arc, we obtained the reconstruct map presented in this inset panel, where the lens collected luminosity reaches down about 1% of brightest peak in the full region. Interestingly, we find that this luminosity distribution from the arc perfectly matches with the position of the faint clump seen here, WE, which is away from the UV brightest peak by 1 to 2 kiloparsec in the reconstructed map from the another multiple. So then this nicely illustrates the power of lensing, making the faintest outskirt emission from the galaxy highly visible, which is almost invisible in the other multiple images, even with the magnification factor around 20. So the C2 line distribution are also reconstructed and find that its effective radius is around 2 to 3 times more larger than the rest frame UV one, while the C2 peak position are consistent within the errors from the rest frame UV peaks, both in the sub-region and full region of the galaxy. So based on the current data depth and resolution, we interpreted that a majority of C2 line is arising from the rest frame UV emitting regions. And thanks to this unique system, we now address the C2 luminosity and star formation relation from the spatially resolved ISM to the full galaxy scales for a typical sub-L star galaxy at the epoch of reionization for the first time. So after the lens correction, we find that both sub and full regions of the galaxy show the relation consistent with the local galaxy relation within the dispersion, while we see that the sub-region of the galaxy show a bit higher ratio, so the C2 over star formation ratio, a bit higher. So to address this slight difference, we also measure the rest frame UV size and plot C2 over SFR ratio as a function of star formation surface density, which is known to have an anti-correlation that is explained like the high ionization state at the high star formation rate density regime causes the C2 deficit. We find that slightly higher value in the subregion is consistent with this known trend here. So this slight higher ratio in the subregion would be caused by the sufficient offset from the UV brightest center, and thanks to it, the ionization state being kept moderate and having a higher C2 emissivity. So given the unbiased aspect of the ALCS survey, our successful at least one C2 line detection allows us to place a lower limit of the, in the C2 luminosity function based on the entire survey volume of ALCS.
It's 2 minutes left, Seiji.
Okay, thank you. So we find that lower limit is consistent with the current semi-analytical models, but we caution that we didn't apply any correction for our estimate, like the completeness correction. So since our sources are spatially resolved and extended morphology, the completeness could be low, and this limit could be pushed up a bit higher. So we thus also derive another prediction by combining the star formation rate function at latitude 6 and the local C2 and the star formation relation, which is shown in this blue line. We find that our and previous constraints are all consistent with this another prediction, which might suggest that the local C2 and the star formation relation is widely valid. So in this last slide, I'd like to give a kind of brief summary and brief discussion. So in this talk, we overview the results in several different scales. So we find that co-spatial distribution between C2 and rest frame UV from the ISM to the 4 galaxy scales, where the C2 and star formation relation are consistent with the local galaxy relation. We also address the statistical results in the C2 luminosity function, which is more or less corresponding to the cosmic scale of the universe, where the prediction based on the local C2 and star formation relation is consistent with all of our and previous constraints so far obtained. So although our result relies on one galaxy, given the unbiased aspect of the ALCS survey and the representative sub-L star galaxy property of our C2 line emitter, our result might indicate that the C2 and star formation relation estimated in the local galaxies might be universal for a wide range of scales, including the spatially resolved ISM, the 4 galaxy, and cosmic scales. Okay, so here is the summary. So the ALCS is uniquely exploring the unique 1 millimeter faint regime, and so we now discover very interesting objects that have been not discovered in previous survey. So yeah, thank you.
Thanks a lot, Seiji. I have a question. So maybe because I don't know about lensing models, so you actually see quite a nice detail in for such a high redshift galaxy. But how much does the actual structure of the ISM depend on the lens model? I mean, how certain can you be that it's like this?
Okay, so can you see my slide?
Yes.
Okay, nice. So so in our team, we construct 3 independent models, and this time, yes, so these 3 models are constructed by independent modelers, and we obtain the consistent interpretation and the consistent magnification values. This is thanks to the strong constraint obtained from this multiple image configuration. So in this case, we think that interpretation and magnification value would be very solid.
Okay.
So yeah, these
cool.
3 models. Yeah.
All right. Thanks a lot.